Hey everybody, I wanted to give you a quick little screencast to show you how you can solve titration calculations. And these are situations where we're adding an acid and a base with the goal of determining the concentration of one of those particular substances. So let's start by looking at a specific example. So the sample that we're going to go through here involves a student doing a titration, much like what we do in lab. And notice that we're given a certain amount. So we know that we are titrating a 15 milliliter sample of a monoprotic acid. And all that means is there's just one hydrogen attached to the acid, HA. And notice it also says that we titrate it using 0.100 molar sodium hydroxide. As you go through these problems, I always find it helpful to kind of underline numerical information that I'm going to need later on. The next sentence reads, the sample of acid requires 9.35 milliliters of the base for neutralization. And that's important because those pieces of information are going to be useful in solving for the concentration of the unknown acid. And then finally it asks us to determine the concentration of the acid. The first thing you need to start with doing is writing a balanced chemical equation for the process. And in this case, it's pretty straightforward. We take our acid and we react a base with it. And remember that in a neutralization process like this, the results are always the same. We're going to have an acid and a base always give us a salt, which our salt would have the formula of NaA, and water. Okay, so an acid plus a base gives us a salt and water. Now, the next thing we want to do is make sure the equation is balanced. Thankfully, in this particular situation, it's balanced once it's been written. So everything reacts in a 1-to-1 ratio. That means 1 mole of acid for every 1 mole of base. And that's important later on in the problem. The first thing we want to do is ask, well, where do we have a complete set of information to be able to move forward? And a complete set for a stoichiometry problem would be something that would allow us to find moles. So to find moles when we're dealing with solutions, we have to remember that we're often dealing with molarities. And molarities are a ratio of moles of solute per volume of liters in solution. Now there's only one of the two things that we have that complete set of information for, and that happens to be for the base. So the first thing we're going to do is solve for the moles of the base. So I'm going to rearrange this equation that I've written here in black, and I'm going to do it color-coded in blue so you know that we're dealing with the number of moles of NaOH. So that's going to be the molarity of the NaOH, which in the problem is given as 0.100 moles per liter, times the volume. Now we have to remember to convert the volume from milliliters into liters. So we divide by 1,000. And when we do this, we get an answer of 9.35 times 10 to the negative fourth moles of base. So once we've gotten it this far, we can take advantage of the mole ratio. And since it's a 1-to-1 mole ratio, we're going to have the exact same amount of acid as reacted with base. Okay, so if we had 9.35 times 10 to the negative fourth moles of base, that means that there had to have been 9.35 times 10 to the negative fourth moles of acid. And you could set that up using a 1-to-1 mole ratio if you wanted to. Since I see the ratio as 1-to-1, I'm not going to take the time to write that. But I can say that now I know that the moles of my acid equal my moles of base. And that's only because this is a 1-to-1 ratio. So that's a claim we can make when we have a 1-to-1 ratio. So because of that, I know that my moles of acid are 9.35 times 10 to the negative fourth moles. Now we're almost done with the problem because remember the problem asks us to determine the concentration of the acid. Now concentration means the molarity of the acid. So in order to do that, we have to remember that molarity is defined as moles per volume in liters. So we're going to take our amount of acid in moles and also take into account this volume of the acid sample and just take a ratio between them. And then we'll be done with this problem. So our final answer just becomes 9.35 times 10 to the negative fourth moles over our volume. And just remember, we have to be careful that it has to be in liters. So divide 15 milliliters by 1,000, and that's our ratio. When we simplify that and give it to two significant figures, we get 0.062 molar, and that's our answer. Okay, so fundamentally all these problems dealing with titration are very similar. You'll be given incomplete values for one of the substances, either the acid or the base, and then a complete set, meaning a concentration and a volume for one of the other materials. Hope this was helpful. You guys have a good night, and good luck with those problems.